Good afternoon, bonjour. My brain is somewhere over the Pacific Ocean right now, and I'm from Montreal, and usually I speak French over there. So today I'm going to speak something like Franglish. So we are celebrating 50 years of software engineering. So my presentation, after a brief introduction, I will be talking about software quality assurance, and I'll be talking about the standards for which I am the editor, the ISO 29110 standard developed specifically for very small entities, very small companies, very small organizations, and I will conclude. So yes, 50 years ago in Germany, they had a first meeting, one of the first known meetings, where they discussed for the first time about software engineering. And in those days, the term software crisis emerged. And as you can read here, a lot of things that they were identifying back in the 68 with over budgets, over the schedule, low quality, do not meet requirements. Those were the issues that were facing the government organizations and enterprises back in 68. Now I wonder if we have solved all those problems. We'll see that later on. And a quotation from a professor from MIT, we built systems like the Wright brothers who were manufacturing airplanes in those days. Okay? We build the old thing, push it off the cliff, let it crash, and start all over again. So the challenge of software development today, still today, we want it faster, we want it cheaper, we want to increase productivity, we want it without delays, no cost overrun, we want to be first to the market and better quality. We want all of that. The bad news is you cannot get all of that all at the same time. Okay? If you don't put the priority where it is, you will not get those advantages. You have to put priority over the quality. So a few years ago, Robert Charette wrote in the IEEE Spectrum magazine that 40 to 50% of work in a project is lost, wasted effort. Now you may say within your own mind that, oh no, that's not for me. I'm a lot better than that. I don't waste 40 to 50% of my time on projects. Maybe I will have a few surprises for you later. So the thing is, if you don't change anything, don't expect different results. The definition of insanity. So the main categories of projects, there are four main categories in a project. So the first one is cost of performance. If we were perfect, if we were not making mistakes, 100% of the budget will go in the cost of performance. But since we are making mistakes, we do some evaluation, we do some testings, we do some reviews to identify the defects. And as we identify them, we correct them. And if we are intelligent, we try to find out ways to inject less defect the next time we do a project. So here you have the cost of performance and the cost of evaluation and the cost of prevention. And since we have to, some of the time, redo documentation, redo coding, redo testing, we call that the cost of rework. And this is that box where I said earlier that we spend 40 to 50% of our project work. Now, I'm asking yourself, do you measure in your software process? Do you measure your software product? So the cost category I showed you before, do you have your own numbers? Any engineering industry, any chemical plant has precise measure about those four categories. What about us in software engineering? Does one of you in the room measure his cost of rework? Please raise your hand. Unless I'm blind, I don't see any hand. Interesting, eh? I told you that we waste 40 to 50% of our budget in wasted effort, and it looks like nobody has ever measured it in their own project. Strange. So if you cannot measure those process elements, I'm really wondering if you're really managing your project. Now, more nasty questions. What is the percentage of defects that you inject? What is the percentage of defects that you detect? And what is the overall quality level that you deliver to your customer? Can you answer those questions like most other industrial engineering organizations? So let me give you one, I will give you just one definition, the definition of software quality. As you can see on the first line, it says a set of activities. So it's not just testing. Testing is a must, but it's much more than that. So we have to make sure that the process that has been developed is the correct process to develop the software or the product you want to develop. And as you are developing your software, we are evaluating both the process and the product to make sure that eventually we will be delivering whatever the customer is requesting. Now, I want to talk about just once about bug. Bug was found in a computer many years ago. It was found in a relay of a mechanical computer. And the operator of that computer, when she found the bug in the computer, she took the bug and she taped it under her logbook. So what you see on the screen right now is the real picture of the logbook of the operator, and you see the real bug. Okay? Now, what I say to my student, in software engineering, there are no bugs. There are errors. Errors made by human beings. It's not an act of God. It's not like you were working and suddenly, through the air, from an invisible place, bugs jumped into your software. Okay? No, we are human beings making errors. So if you want to kill bugs, I have a product for you. Okay? But there are ways to kill software errors. So just a quick look at one of the best-known author, Watts Humphrey, that was at the SCI at that time about testing. He says, in a small project, small program we have a few if-then-else conditions, about one branch per 10 lines or so. So if you have a simple project, a simple software, we have just a few branches. But as we grow, as we increase the size of the software, you can see on the right side, the number of paths increases exponentially. So the bottom line is, it's impossible to test all the paths. We have to find other ways. So I say again, testing is an absolute must, but we have to work and find out other ways to eliminate the errors. So let's see, on the horizontal axis, you see the typical phases of a project. And on the vertical axis, you see the number of defects. So you see the requirements phase, high-level design, low-level design, and where there is the red line, vertical line, there is a coding. Then unit testing, integration testing, system testing, and shipment. So normally, this is the actual development of a project. Defects will be injected as we develop the software, okay? And eventually, we'll start doing the testing once the code is ready, okay? We cannot test, we can hardly test requirements at that time. So what I'm asking yourself, what are the problems with this approach? So I'll let you read that. So as you can expect, we'll have a lot of rework. And as we are fixing errors, we could have a very unstable process. We will be wasting a lot of time. Developers will get frustrated. Most of the time, we'll blow the budget, we'll blow the schedule, and maybe the customer will not be happy. So let's find another way, right? So we have the same curves, but let's work smarter. Let's do reviews. Let's do reviews as we go along. At each step of the process, we do a static analysis and we detect defects. So the less defect, the more defect we detect earlier, the less defect we'll have to fix in the testing phase. So we do reviews at each step of the process. So the thing is, we should be working smarter, not faster. Working smarter by detecting injected defects at all steps of the process and removing them. So this is a curve from a company that produces aerospace devices. And what you can see, if you do the maths, about 70% of the defects are injected in the requirements phase and the architecture phase. So 70% of the total defects of that project are injected before one line of code is written. But most of the organizations that don't do reviews will detect those defects only in testing. So now you understand why maybe you're wasting a lot of effort, of energy, because you are detecting those requirements and architecture defects once the code is written, once the tests are done, and you have to go back, modify the requirements, modify the architecture, modify the code, modify the test cases, and rerun the tests again, all over again. And if you're smart, and if you introduce reviews, at least one of those things, naturally you need stable process, you need documented process, but by having reviews, you would have, you can increase the percentage of defect removal up to the 90% level at each step of the process. So see those as filters, filtering out defects at each step of the process. Okay. So the best question is, okay, once you know where you make defects, the next question should be, how do I prevent those defects to be injected in the process first? So let's have a look at the house of quality that I'll be showing to you during the next 20 minutes or so. So the base, one of the elements that we have for the house of quality are references, standards, models, defect categories. We have reviews, we have audits, we have the code of ethics, we have risk management, and we use all of those components to eventually assemble them to make a software quality assurance plan. And this will provide a stable foundation to have stable processes, capable processes with continuous training, continuous improvement to produce good quality software and satisfied customer. And one of the elements of the foundation, we will have effective and involve software quality assurance people. And we need strong support from management, because without strong support of management, the house of quality will collapse. So let's have a look at most of them. So the first one is requirements, the quality requirements. So here the definition of quality, using standards, because I'm taking definition out of standard that you can buy, you can purchase on the web. So definition of quality, we mean conformance to established requirements, right, to satisfy stated or implied needs from the customer, and naturally that product has to work under specified conditions. The next one is business model. Each business model, it means that for each type of business, there is a way to make money and there are ways to lose money. And this is an example of business models. So you produce software inside, you produce software for customer outside, you produce for mass market, you produce for firmware. And for each of those business models, there is a way to make money and there are ways to lose money. So each business model will implement software quality practices to reduce the risk of losing money. Talking about quality models, again, there is a standard that defines different qualities, like maintainability, like security, portability. And for every one of those elements, of those characteristics, the standard will give you a proper definition of the components of, in this case, software maintainability. And for each of those components, you could be able to define metrics to be able to measure that. And there is even a consortium in USA with members all over the world that has produced software to automate the measurement of software quality measures. Let's move on to software quality, the cost of quality. I talked about that a bit earlier. a recent report in the States that was issued just a few weeks ago about cost of quality. Basically, they say organizations do not measure the cost of quality. And when you don't measure the cost of quality, you don't have the data to make right business decision about where to invest in order to reduce your cost of quality. The number in USA was $2.6 trillion of wasted effort in 2018. And the model they use in this report that you can get, by the way, if you go on the CSIQ website, you can get the report free. There is a visible part of that model, the things that you see, but like an iceberg, there is a lot of things that you don't see that have impacts either the software, either the process, or either the customer or your business. And you will have to pay for that, that's for sure, one way or another. Continuing, cost of ethics. Things are getting complex. Kids are getting smarter. Kids have been getting things on the internet free. They have a different mindset, at least in Canada, than in certain countries. So we have to teach them the code of ethics. Okay? You have to know what we mean by ethics. And by the way, it is freely available in 9 languages. Unfortunately, it's not available in Korean, but nothing prevents you from translating it in Korean. So there are 8 principles that supports the code of ethics. And the first principle is the public. It means everything has to be done having in mind always, the top priority is the public. The care of the public comes before the care of the manager or the care of the colleagues. Let's move to standards. There is a wide portfolio of software engineering standards. Here I show you just a few examples. For those of you who have done some physics or chemistry a few years ago, those are some laws of physics, laws of mathematics, laws of optics, laws of chemistry, like Ohm's law. So my question to you is, can you name a law of nature that supports as a foundation software engineering? I'm waiting for your answer. There are none. There is no laws of nature that supports software engineering. The only thing that we have to help us, to guide us, are the standards. That's the only thing we have, and they will never be as good as a law of nature. Okay? So there is here, I list here 11 reasons why you should use standards. Okay? As you may know, I've been a member of the ISO Standard Committee since 2002. Okay? I came to Korea in 2002. I went to Busan for one of the ISO meetings. So standard is the foundation for software engineering. Unfortunately, standards cannot guarantee you, like a law of nature will guarantee you the output. Software engineering can give you can increase the level of confidence that you'll be delivering to your customer the objectives that you have agreed with at the beginning of the projects. But that's the best we will ever get. Standards will improve. Every 5 years or so, we produce a new version of the standard. We improve the standard. We find defects. As we learn, we document this in the standard. So this is the committee that's responsible for software and system engineering. Right now, the portfolio is about 179 systems and software standards, with about 47 in the process. 37 countries, including Korea, are participating to the development and review and maintenance of standards. Reviews. So it is a very important practice, very cheap practice, low cost, very efficient. So if you have money to invest in just one software quality practice, I would ask you to look at doing reviews. And there are companies that do review, as I show you, at every step of the process, because you want to detect defects, even in project plan, even in the contract. For those of you who have signed contract, you know that there are dozens and dozens of defects and mistakes and ambiguities and contradictions in contracts. So reviews are applicable at each stage of the process. And I'll let you read this statement from Jerry Weinberg. So in other words, doing reviews is accelerating your learning, because you're learning from your own mistakes and you're learning from the mistakes of your colleague. So if you're bright enough, you are registering in the back of your mind the type of mistakes you make and the type of mistakes that other colleagues are making, so that when you write other documents or the codes, your background processor works on those mistakes to prevent them. And this is a list of different types of reviews that you can practice, from very low-cost individual review to more formal reviews. And you should have a copy of my slide later on. Once you have you do reviews, you can draw a table like that where you'll see where the defects are made, where the defects are detected, and when there is leakage from one phase to another, and you can make computation. In this case, in the requirements analysis, we find out that by doing the computation that 83% of the defects made in requirements analysis stage have been detected in that phase, and 17% of the defects have leaked through other phases of the process. The good news is the percentage of defect removal efficiency or detection efficiency improves as you learn and as you practice. For those of you who know CMMI, at the level 1, you detect 1 out of 2 defect, and as you get better, you can go up to the 90% plus defect detection effectiveness. Audits, that's another software quality assurance tool. It's a third-party evaluation, so some people who have not participated to the project, we evaluate the process, we'll evaluate the product to make sure that the process that has been approved is used, and the documentation that were supposed to be produced are produced at the proper quality level. So audit can be done internally or externally. Verification and validation, we are asking ourselves in verification, are we doing the product right at each step of the process? We are doing reviews, are we doing the product right? And validation means, are we doing the right product? Because you could be doing the product right, but doing the wrong product. So this shows each step of the process verification activity, which could be a review, it could be a test, it could be an evaluation, a simulation, a demonstration. Traceability, very important and very easy tool to use to be able to trace from the customer needs right down to the end, to the approval of the tests. In this case, we have done the product right, but we haven't done the right product, right? So we missed just one element in that traceability matrix. Give you an example, a real project, the Mars Polar Lander that crashed, okay? Naturally, it crashed, so we didn't send any people over there to find out what happened, but the most likely cause was that there was an engine failure. So how this thing works is at each end of that tripod, there is a contact sensor. And as the Polar Lander was descending over Mars, the legs were opening and the sensors were seeing a glitch, a signal, a transient signal, and the system engineer said, ignore this signal, okay, because it's not the signal that says that the lander has touched down. Please ignore this signal because the real one will come up later on. And they forgot. So here you see in red that what the system engineer wrote, he says, however, hey, do not take into consideration this signal until you reach 40-meter high. And the thing, unfortunately, this system engineering specification did not get transformed in software engineering specification. So what happened was this, is as soon as the computer detected that signal, it shut down the engine and the solar lander crashed on Mars. Checklist, very important to help developers in focusing on one item after the other to identify defects. Now, most of my students and most of the people I work in industry with companies around the world, I've been working in Asia and America and European countries, and we don't very like to use checklists. It's painstaking, it's not much fun. But there is an hypothesis from Gawande says, no, maybe because we have a big ego and we say, oh, we don't need that. I'm too good for that. Why should I bother about the checklist? Unfortunately, we missed an opportunity to improve a lot our defect detection efficiency by using checklists. Configuration management, we're asking ourselves who make the changes, when are changes made, what changes are made, why are they made? Because in a project, we have the initial requirements, and as we go along, in a 1, 2, 3, 4-year project, we delete some requirements, and we add some requirements, and we modified some requirements. So if we have a change rate of about 1% per month, which could look like negligible, it's just 1%. Imagine 1% per month after 2 years means that 24% of the requirements have changed. This is why traceability is important. This is why configuration management is important. This is why discipline is important. And this is why policies, processes, procedures, and quality records are important. Because at the policy level, we see why we do things. And as we go down, we explain what we have to do, who will do that, and eventually we have the procedure level that describes in details what we have to do. And at the bottom line, the evidence, the documentation, the proof, the emails that demonstrate that the process has been used correctly. Now, the mistakes that many organizations have made during many years is to focus their improvement in improving the process. They found a new model, they found a new standard, and they said, let's improve the process. Okay, I agree that we have to improve processes, but we should work the other way around. We should ask ourselves and ask the business people at the top, what are the business goals? And we derive from that requirements like software projects, and out of that, we see what prevents us from reaching those goals, and how can we improve the process to help us achieve those goals. Measures, as it's written here, if you don't measure, you don't control, you don't manage. So measures allows you to make decisions. That's the purpose of measuring. Making decisions about quality of the process, about what we have to do next step. But measures have also a secondary impact, and I'll let you read this cartoon. Human beings do not like to be measured. At least in Canada, we don't like to be measured. Software engineers do not like to be measured. So we have to be very careful when we measure things because there could be side effects about measuring. What we want to do is we don't want to measure the individual. We want to measure the process. We want to measure the capacity of the process, the productivity of the process. And then we'll find ways to improve the software engineers and software people. State of measurement, you can see here that from different sizes of organization, a study made by the SCI, small organizations, medium and large organizations. And if you look quickly, most of them, they do about all the same thing. We ask the question, I use measurement to understand the quality of the product and or services of which I'm working on, and about what, 40% plus or minus 10% are doing it. So we are not measuring, unfortunately. Risk management, there are many risks inside the project and outside the project. And as Tom Gibbs said, if you don't actively attack risk, they will actively attack you. Okay? Even if you ignore them, risk will pop up. And all software have risks. Don't be disillusioned by that. Supplier agreement management, if you have to buy components from a supplier, you should be looking for the same thing that you should be doing inside. And this is an article published many years ago by Krasner about computer litigation. And he says, no, if you want to go in court, if you have to go in court, you have to bring evidence to the judge. And he says evidence that will be, the judge will be asking will be metrics. If you have the technical metrics, the quality metrics, the process metrics. Unfortunately, as we said before, not too many people are measuring. And we have to have a documented, implemented, a stable process. And we have to document the objective, we have to document the plan. Okay. If you don't have that, and you get in court, most probably that you will get into trouble. Okay? And when I say documented process, you don't need a 10-page report to demonstrate that you have been meeting with the customer. You could have an email exchange. You have met with the customer, it could be on the phone. Okay? You have met the customer, you have talked with the customer about modifying requirements, adding requirements and things like that. And at the end of that discussion, you have agreed to do something. So when you get back to your office, you write a five-line email saying, today I talked with Mr. So, Mrs. So-and-so, we have talked about this and we made that decision, and you send this email to your customer. You have now an evidence that you had a meeting and you had the conclusion. So we're not asking for a lot of paperwork, but you have to demonstrate things. So software quality assurance plans will put all those things together, assemble that, such that you'll be able to develop your process, manage your process, develop your product, and evaluate your product. So on one side, you have the process assurance. Okay, we want to make sure that the contracts will comply to the laws and regulation of the country, and the process will conform to the contract, and the plans will conform to the contract and things like that. And the bottom part, you have the product assurance. We want to verify at each step of the process if the product that is being produced conforms to either the contract or the requirements and things like that. So software quality assurance, now I'm changing my hat, I'm putting my marketing hat here. So all that I've showed comes from this book that has been published a few months ago. So if you want to read more about the House of Quality and the different elements, I'm saying that, but as for those of you who are authors, you don't get rich by writing textbook, okay? So in that book, you have about 40 years of experience from my co-author and myself working in telecom environment, in transport environment, in the defense environment, and so much more than that. So let's have a look to standards. Okay, I want to show you the standard for which I am the editor. So I'm switching hat again. I'm talking to you now as the lead editor of the standard for very small entities, the ISO 29110 standard. So this is the statistic from European countries. What I want to show you is there are lots and lots of small and very small organizations. In this case, in European countries, as you can see, micro enterprises, less than 9 people, is 92% of the total number of companies in European country, and another 10 to 49 employees is 6%. So below 49 employees is 98% of the total number of companies. Those numbers are from European countries, but I've been around the world many times, and in most countries, it's similar. It's very similar. Okay, there is a pyramid where you have a very small number of big companies and a very large number of very small organizations. So, sorry, I went too fast. So what do we mean by VSEs? We mean organizations, a company, could be profit-making company. An organization could be a government organization, a non-profit organization, a project or a team having up to 25 people. So this is an example of the pyramid of a manufacturer of electronic devices. Okay? And one defect was made in the component developed by one of the low-level supplier and was not detected, and that defect did cost $200 million to the manufacturer to fix the problem. And what I want to show is According to the definition, there are VSCs at every level of the organization. I was making a presentation 2 years ago in Paris, and I had in my workshop for VSCs, I had people from the small company called Airbus. It's a joke here. And I say, sorry, are you in the right room? Because it's a room about VSCs. And the guy from Airbus says, yes. And other companies, we have people from other big companies. He says, yes, because, he said, for large projects, we have large processes. But for small projects, sometimes we don't have small processes. And we would like to find ways to make interfaces between the big process for the big project and to have small processes for small projects that they can talk the same language. So again, the C7. So those are the flags of the country that are participating to my working group. As you can see, a lot of organizations around the world have been members of my working group since 2005 when it was created. So a quick overview. Now you see here the typical waterfall approach of developing software. So there is a 29110 for software development. For those of you who are developing hardware, there is a 29110 for system development, and naturally, we manage that those two to talk to each other. So if you are producing hardware with software components, you can use the 29110. We have provided a roadmap in 4 stages. So we know that at the beginning, some organizations start very small, like startups. 2 or 3 people that get together, they create the company, and we say, let's work smart. Let's use a small process, and let's build on it. As they grow, we have a basic profile for the people that work on one project, one team at a time. And as they grow, we have the intermediate profile for more than one team, more than one project at a time. And we have what we call the advanced profile. We want to make sure that the startups will not die because the dying rate of startups is very high. About 80% die within 5 years. So we say, let's find a way to help them grow and sustain. So the profiles are like the Russian dolls. The entry profile is a subset of the basic profile, and the basic profile is a subset of the intermediate profile. Okay? So you don't have to relearn at each stage. And we have managed to make it correct such that, yes, you can work with different types of life cycle. You can also work, you have to produce some documentation. You can also work in Agile mode. We have developed documents to address your needs. So we have a part 1 for everyone. Okay, it's called the overview. We have developed standards. Standards, by the way, defines what you have to do. We have developed guides, and guides tells you how to do things. So this is where the important part of the standard is for VSE, is in the management and engineering guides that tells you how to do things. And I'll give you an example in a few seconds. And most of them are freely available on the ISO website. So this is an example of the basic profile, one project, one team. On the right side, you see the standard steps of software engineering. And we have added a project management process because we know that technical people are not very good at management, or they don't like very much management, but we know that if you fail at management, most of the time your project will fail. And you have the interface with the customer. So see those as Lego blocks. So we are not imposing a life cycle. You can select the life cycle that you want for your own project. So this is an extract from the guide. You see on the left side, we define the roles. In this case, the customer and the analyst will work together to validate and approve the requirement specification. And there is some amplification of what it means. We have as an input product the requirement specification that have been verified before internally. And at the end of that meeting, we have the validation results, which demonstrate that we have done through the requirements with the customer. We may have some modification to do, but that has been recorded. And now we have validated requirements, which they become their version 1.0 baseline version for the development of the project. We also document every type of document that you have to produce, in this case, change request. So we explain to you what is a change request, and we propose to you a typical content of a change request. And there are different statuses for a change request. And we say that change request can come from the customer, it can come internally from project management or from the software developers. A quick overview of implementation. So an IT startup in Tunisia and in Canada that used this basic profile as a foundation, and because his customer wanted to have a CMMI level 2, but a startup can hardly start with a CMMI level 2, it will die before it starts. So by putting in place a basic profile, it's a nice way. A large bank, a large Canadian bank, over 3,000 employees in the IT software sector, and there was a team of 6 people that were developing software tools for traders that use Agile mode to develop the tools. A large public utility, this is the Quebec electricity provider. Again, almost 2,000 people in the software domain, maintaining over 2,000 applications, and a team of 11 people used the basic profile in Agile mode. And a startup in Peru that produced, again, using the basic profile product for insurance company. So this is the data coming from a publication about the CMM. What I want to show is, remember the percentage of rework. So on the left, you see 41%. That company, that was a defense contractor in the United States, when that company was at level 1 of maturity level of CMM, they had 41% defect. And as they invested, they went from 41 to 18 to 11 to 6 eventually. So one of the startup, the Peruvian startup, for its first project, using for the first time the basic profile, had only 18% rework. The IT startup had 12.6%, and the utility provider had 10%. So what I'm saying here, if you use proven practices documented in standard, you don't have to reinvent the wheel. You follow the guide intelligently, and this will prevent you from making mistakes. This will make you much more efficient. Switching to teaching. So here I show the flags of the 19 countries that are teaching 29110, 19 countries that I know that are teaching 29110. I don't know about Korea, so if someone can tell me eventually in the hallway if Korea is teaching 29110, I'll be more than happy to talk with those professors. If you want to know more, you can download the IEEE Computer article of 2016 that gives you an overview of what is 29110 and the accomplishment we've done so far. And if you want to read more about implementation, you can look at the 2018 article of IEEE software that describes in more detail what I've talked to you very briefly. You can also go on my website. It's a public website in 3 languages, so you can download information, you can download pilot projects, you can download case studies, you can download freely available documents, and there is linked how to go to ISO website to download free documents. So recommendation about software quality assurance for and 29110 for academia, I would say, hey, please teach those practices in your courses and also in your projects. Okay? For government agencies, implement those practices in your project. Educate also your supplier about SQA and 29110, and motivate your suppliers in implementing those things. For company developing software internally, implement SQA and 29110 in your own projects. And for customers, motivate your suppliers in getting better, because the better they get, the better product you'll get. Okay, you will meet your budget, you'll meet your calendar, and you'll have the quality that you wanted or that you hope you'll get. And for supplier, implement those SQA and 29110 process. Educate your customers also, because there is a price. The thing's free. There is no free lunch. So if you put reviews, you will have to spend some hours to do them, but you will detect defects and provide a better quality product to your customer, and also communicate to academia. Okay? So going back to 1968, yeah, this is the sentence I showed you earlier. In 2018, where are we? I'm saying here, many organizations are still building systems like the Wright brothers built airplanes. Eh? They build the whole thing, push it off the cliff, let it crash, and start over again, right? Unfortunately, that's what I see when I go around the world. Conclusion, SWE provide a wide spectrum of proven software quality assurance practices. Software quality assurance can increase the level of confidence that you will deliver to your customer quality software within budget and schedule. And 29110 standard has been developed specifically for very small entities, meaning up to 25 people that develop software and systems. And there is a roadmap, 4-level roadmap, that will allow you to move up as you grow in maturity. So celebrating the 50 years of software engineering, my last thought, I'm asking myself, why do a large number of software organizations either ignore the existence or don't use software practices that have been available since 1970s? Why? Is it because many software developers and software managers have a big ego? Probably yes. Why are so many software people not working smarter and not using the proven practices? And software engineering must address its sociopathic traits, commonly defined as antisocial behavior, impaired empathy, and bold, disinhibited egotism. That's all, my friend. Thank you very much.
네, 질문 있으신 분은 자리에서 손을 들어주시기 바랍니다.
Very interesting presentation. I really enjoyed some of the slides. However, being a practitioner of software testing and as a tester who is contributing to software development on day-to-day basis, I feel alarmed and concerned at the same time. I would like to know from you, with the advancements of methodologies like Agile or Devops, with the increasing adoption of industry towards this, do you really think we need standards that could apparently slow down the whole thing, be it for small enterprises or even bigger one? Do you really think standards are relevant in an era where people and interactions are more important than processes and the standards and the percentage?
For many people, they think that a standard will immobilize them, that standard will crush their creativity, and standard will be in the way. It could be that way if those who implement it this way. So if the people have a mindset like this is what will happen. But standards is documented knowledge. So if you want to ignore documented knowledge, I will say, be my guest. But what I've observed when I go around the world for our meeting in ISO, we're still in the 1970s in many places. Yes, there are companies that are in 2018. Yes, there are companies that are at the top, that are doing the things correctly. But I would say the Pareto rule, 80-20, I would say that 20% are doing 80%, okay? And what I see is not very nice, okay? Unfortunately, I think academia has been lagging a lot for all sorts of reasons, because in academia, people are rewarded for publishing, for doing research. And unfortunately, what I've seen is academia, at least in computer science and software engineering, sometimes they don't even know the existence of software standards. So how can they teach their students about standards when they don't even know about them? And yes, it could get scary to read a standard. So this is why in 29110, when we did our survey, we did a survey around the world with 35 countries, and the answer was, please provide us with guide, provide us with examples, provide us with usable material. Remember I said the standard explains you what you have to do, but not how to do things. So yes, I agree with you. If you give standards to people, they will say, I read this, but it doesn't help me very much. So this is why with 29110, the management engineering guides explain you how to do things. Now this is, I'm caricaturing a little bit, it's like a recipe, okay? You take this document, this guide, and you follow the steps. And you apply the steps intelligently, so it will guide you to do, not to forget anything, and it will guide you how to do things, and all the members of your team will know what you have to do. All the members of your team are part of that same project. So this is maybe the difference between the perception of standards, the big standard. Don't forget that standards have been developed by big organizations to serve the needs of big organizations. So they are pushing the technology and they are documenting what they have discovered. But remember the pyramid at the bottom of that pyramid, and even at the middle of the pyramid, they're not participating to the development of standards. What they want is usable material, accessible material. I didn't mention that here, but 29110, normally a standard in ISO is published only in English. Software standards are published normally in English. In our case, lots of countries decided to translate the standards and the guides, especially the guides, in Spanish, in Portuguese, in Germany, and even in Japanese, okay, to lower the bar, so to make the guides more and more accessible to their people, to their students in their country. So did I answer your question?
Not really, but I have a bunch of questions for you, and we can take it offline. I would let other people ask more questions.
Okay. Other questions?
Hi, very interesting. I noticed that you said your standard was for very small companies in range of like 25 to 50 people.
From 0 to 25.
0 to 25. Why in an organization that small can people just not talk about what they need to do and how they're going to do it? And why do they need a standard to follow?
Most of the people that I've seen, they have not received the proper education to do complete software engineering. So what we decided to provide to them is a roadmap and a guide for them to do the right things in the right sequence, not to forget anything, such that they don't have to redo the project once or twice again. We did a few pilot projects in France recently, and one of the things that some startup discovered, they say, now that we have a process, now that we have used the process, now we can envisage growing up, hiring people from outside, because we have something that we can teach the new employee about the way we work inside. So now they have the base, the foundation on which they can grow and evolve, instead of reinventing the wheel. So that's the problem, is most computer science people like to reinvent the wheel. And it's also applicable to small teams, because in a large enterprise, you could have small teams of 2, 3, 5, 6 developers, like the example I showed you in a bank and a big utility. Even if they have 2,000 or 3,000 IT people, they had they had dozens of small projects with a team of 6, 7, 9, and 10, and they didn't have any process. And if they applied the big process, the CMMI level 3 process of the big project, they will die. Okay?
So this is to solve a training issue for teams that don't have the experience in the training.
One thing is a training issue, but if they had received good education in computer science or software engineering, and if they look at the guide and they are open-minded, they will see, because we haven't invented anything new. We have just captured and formatted just enough material, okay? Because as I showed you, there are over 180 standards. So you can get lost in that forever. So we have picked and chosen different practices that are applicable for a small size organization. And this is why we have a roadmap. We say, as you grow, go and get to the next level, and eventually you should be an adult, a mature organization. Now that you know more, go and pick up what you want in other standards.